All right, everybody, we're going to talk about special products and grouping in this lesson, section 5.2 from the book. And when we factor by grouping, first of all, grouping usually applies to a four-term polynomial. Okay, so we have four terms in the polynomial, and we basically do GCF factoring three times. So first we factor out the GCF from the first two terms. Okay. Then we factor out the GCF from the last two terms. All right, so the first two terms, last two terms, and then we factor out the common binomial. And so we should see a binomial that matches up, and then we factor that out, okay? So let's see some examples and try to make sense of this. So if we look at number one, we have a four-term polynomial, right? Four terms there. And basically what we want to do is we want to think about these first two terms first, and then we're going to deal with these second two terms, okay? All right, so the first two terms, I'm going to find the GCF. So what's the GCF between x, y, and 2y? And it would just be y, right? Y is the greatest common factor. So I'm going to bring a y out to the front, and I'm going to leave the leftovers back inside. So it'll be x plus 2. All right, so I divided by y, right? And then I put the leftovers back inside. All right, so now I'm going to do the same thing with the second binomial. So what's the greatest common factor between 5x and 10? And you might be thinking 5, right? Hopefully this is becoming common or second nature to you, right? And so then what we have left is x plus 2, right? If I divide 5x divided by 5, I get x, right? If I divide 10 divided by 5, I get 2. All right, so now you might recognize that we have a binomial in common, right? Both of these terms have the same binomial. And so what we can do is we can factor that out, right? This is a common factor now. So we can bring that to the front, x plus 2. And then we have our leftovers, which are y plus 5. Okay, so remember what we're doing is we're dividing by x plus 2, so that'll cancel this out and we just end up with y, right? Same thing when we do it to this, right? If I divide by x plus 2, this will go away and I'll just get the plus 5. Okay, so that's our final answer there. All right, so we go from a polynomial with four terms to a product of two binomials. All right, let's take a look at number 2. X squared. We're going to take x squared and wx and factor out the GCF. So here, they both have an x. We take the one with the smallest exponent, right, which is a 1. So that's our greatest common factor. Our leftovers, if we divide x squared divided by x, we get x. Wx divided by x is just w. All right. Now for the second binomial, there is no common factor, right? So basically we're going to factor out a 1. Okay. And then we put x plus w back inside, right? If we divide x and w by 1, we get x and w. So now we have a common factor, x plus w, right? And that should always happen when you're doing grouping, is you should have these binomials match up. So then you bring that to the front, x plus w, and then your leftovers are x plus 1, right? Now, there it is. All right, number 3. GCF between h squared and hk is h. So I'm going to bring h out to the front. And then left inside is going to be h minus k, right? H squared divided by h is h. HK divided by h is k, right? And it's a negative divided by a positive, so we end up with a negative. All right, and then here, our second two terms, we're going to have the GCF here is going to be R, right? So I'm going to bring out a plus R, and then the leftovers are going to be H minus K, right? Just like we thought. So then the H minus K comes out because that's common, and the leftovers will be H plus R. All right, number 4, we have a little more going on here. Same idea though, GCF between the first two terms is going to be X. Our leftovers will be X minus 2Y, right? X squared divided by X is X. And negative 2xy divided by X is just negative 2y. Okay, then we're going to factor out the GCF from the second terms. So the GCF between 4 and 8 is 4, right? The numerical GCF is 4. And they both share a z, so it's actually going to be 4z is the GCF. So if I divide this by 4z, I'll just get x, right? If I divide this by 4z, I'll get negative 2y. All right, and there we can see we have our matching binomial. So now that becomes a common factor. We can bring that out to the front. And our leftovers are going to be x plus 4z.